The size of the different object, it varies with respect to the radius or with respect to the wide range, and it ranges from 10 to the power of minus negative 15 to positive 26. Gravitational forces acting over it and gravitational forces exerted by the Earth. Measurement of mass of atoms and molecules, and which can be usually done, that is the smallest particles can be measured with one concept, and that is nothing but atomic mass unit. Hello everyone, I am Vrinda, Faculty of Physics from Vidhyaashram School of Excellence, Mysuru, welcoming you all to session 2 of chapter 2, and chapter name is Units and Measurement. In today's concept, we are studying much more about the measurement, that is in case of size. So here, estimation of very small distance or the size of the molecules is being seen over here. In order to estimate with a very small size like atoms or molecules in such a way, we have to use certain set of instruments, and it varies from microscopes to telescopes. It keeps on varying. Understood? So now here we have a microscope image over here. So this is useful in order to observe the very smallest images or the smallest particle in the universe like atoms or molecules. We have different types of microscopes which is present over here. That is, it can be optical microscope, it can be tunneling microscope, and electron microscope, the one which is very much useful in order to identify the smallest particles of certain range. As the range increases from smaller to bigger, it is like we use, instead of microscopes, the telescopes have been replaced. So that is all about your measurements, wherein you can measure the smaller size of 10 to the power of minus 8 to 10 to the power of minus 10. Okay. So now we have got range of length. In case of range of length, we see the radius. Smaller radius till the bigger radius. Okay, so here you can see few of the range example, that is the size of the different object, it varies with respect to the radius or with respect to the wide range, and it ranges from 10 to the power of minus negative 15 to positive 26. 0 point, so many zeros and 1 or 2 or any number and that many zeros next to that point. That means to say that very smaller range to very bigger range. This is the smaller range which comes like 0.000000. It keeps on going, and this is like 1000000. It keeps on continuing. Understood? So this value is very much smaller and this value is very much greater. So there is a different object which ranges from this part to this part. So that is 10 to the power of minus 15 meter to 10 to the power of 26 meter. All the length in the universe is being considered to be the SI unit. That is why they have given it in meter count. Okay, so for example, if you can see, there you can see the nucleus. So size of the nucleus is of the range 10 to the power of minus 15 meter. So it can be called as 10 to the power of minus 15 meter. Then you have got size of the hydrogen atom, which is said to be 10 to the power of minus 10 meter. Radius of the earth is 10 to the power of 7. Distance of the moon from the sun is called as 10 to the power of 8. Distance of the sun from earth is called as 10 to the power of 11. Size of the galaxy 10 raised to 21. Distance of the boundary of the observable universe is 10 raised to 26. So it ranges from the size of the nucleus to the distance of the observable universe. Till here it ranges. This is what exactly they gave the range of the length, and how can it be measured. And you will get to know it is measured in terms of meter as a SI unit. And this distance of the sun from earth can be called as astronomical unit. Okay, so next you can see here, these are the one like in order to show the distance, like how exactly it varies, I have given an image over here. You can observe this. Next we are getting on to the range of length itself. That is, some special lengths are there wherein it has got certain set of names. Instead of calling 10 raised to so and so magnitude, this will have a value, that is a name to be called in short. That is, suppose for 10 to the power of minus 15, you can call it as 1 Fermi. 10 to the power of minus 10 meter, you can call it as angstrom, 1 angstrom. And 1 astronomical unit is said to be 1.496 into 10 to the power of 11 meter, which means to say, what exactly is your astronomical unit? It is nothing but distance from sun to Earth. Sun to Earth distance is nothing but astronomical unit, and it is nothing but 1.496 into 10 to the power of 11 meters. That is called as this value. Whichever value gets like this, you can call it as, consider it as 1 astronomical unit. And astronomical unit is the distance between the Sun as well as Earth, and 1 angstrom is minus 10 to the power of minus 10 meter, which can also be called as angstrom by using the symbol A naught. Okay, and 1 form is 10 to the power of minus 15 meter. So having this concept and this concept, we can just, for the previous slide, we can just name this as 1 Fermi. Size of the nucleus is 1 Fermi, and size of the hydrogen atom is angstrom, 1 angstrom. That is all, like how exactly you give it in short. In further classes, you will study much more about like the shortcuts, like the short names, short and cute names which is given to this powers. Okay. Next, you are having 1 light year. So now, what is meant by 1 light year? 1 light year in the sense, the distance a light travels with its own velocity, that is 3 into 10 to the power of 8 meter per second. Distance, the light traveling with the speed of 3 into 10 to the power of 8 meter per second throughout 1 year is known as 1 light year. And what is it? 9.46 into 10 to the power of 15 meter. Okay, so this is known as 1 light year. So what is 1 light year? Light year means it is distance traveled by light which is moving with velocity of 3 into 10 raised to 8 meter per second in 1 year is known as light year. So that is all about your light years. So what is the value? 9.46 into 10 to the power of 15 meter. Next, we are coming on to 1 parsec. 1 parsec, it is nothing but, it is known as distance at which, it is the distance at which the average radius of Earth's orbit around the Sun. It is the average radius of Earth's orbit around the Sun subtends an angle of 1 arc second. Okay, this is known as the parsec. Parsec, it is a distance at which the average radius of Earth's orbit around Sun subtends an angle of 1 arc second is the concept of your 1 parsec. And what is the value? 3.08 into 10 to the power of 16 meters. So these are few values which you will have to keep it in your mind. 1 Fermi means 10 raised to minus 15 m. Angstrom 10 to the power of minus 10 m. Astronomical unit as 1.496 into 10 to the power of 11 m. Light years 9.46 into 10 raised to 15 m, and you have 1 parsec is nothing but 3.08 into 10 raised to 16 m. M means to say that it is meters, which is the SI unit and which is used to measure the length. Next, we are going on to measurement of the mass. How exactly the mass is measured? And what is mass? Mass is nothing but it is a property of matter. By looking at this, can we decide mass is equal to weight? No and never. Mass is different and weight is different. Mass means it is, if you're having any of the objects here, the particles or the matter which is present in the particle is said to be, or an object is said to be the mass. So what is mass? It is a property of matter. The property which is present in this matter is called as mass. But what is weight? Weight is nothing but the gravitational force which is acting over this mass is nothing but weight. So mass means only this part, weight means G as well as mass. Understood? So what is weight? Weight is the product of mass and acceleration due to gravity is weight. But what is mass? Mass is just the property of matter. Got it? So there are differences between mass and weight, but both are calculated in terms of kg. Remember that. There is difference between mass as well as weight, and the differences in case of SI unit also exist. Okay, so now you can consider that mass does not depend on which are the quantities. That is, one is temperature. It never depends on the temperature. And mass doesn't depend on the pressure. Mass doesn't depend on the location in space. But in case of your weight, it depends on these things, temperature, pressure, as well as location in space, because gravitational force is acting over it, and gravitational force is exerted by the Earth. Okay, and each and every planet in the universe has got certain set of gravitational force in its own planet, because of which certain objects weigh in a different way. So whereas mass is a stable one which has no dependence on temperature, no dependence on pressure, and no dependence on the place where exactly it is placed. Okay, next is the SI unit of mass is given by kilogram. In short, it can be considered as kg. Kg means it is kilogram. And next, how can you define mass? Exactly by taking what, in case whenever you're doing experiment, what was considered as a base foundation for the mass, and that was nothing but they took a fixed numerical value, that is h. H means to say that it is Planck's constant. And what is the value of h? It is 6.62 into 10 to the power of minus 34 joules kg meter square per second. So this is all about your unit of Planck's constant. Having this as a base, they just introduced the concept called as mass. So you just don't have to worry about these values, but you'll have to know how exactly it was defined, what exactly was taken in order to define mass. That is the Planck's constant, which was termed as h. And what is the value of h? That is Planck's constant. H is known as Planck's constant, and the value goes out to be h is equal to 6.62 into 10 to the power of minus 34 joules, or it can also be called as kg meter square and second inverse. This is exactly the concept of mass. So I want you to know the difference between mass as well as weight. Okay, never forget the difference between mass as well as weight. Mass is the one which occurs individually as mass. That is the property of the matter. Whereas weight, it is like it just fuses mass with the gravitational force of attraction of certain planet, whatever you consider. Understood? So that is all about your measurement of mass. Next we are going on to the measurement of mass of atoms and molecules and smaller particles in this universe. How exactly the mass of smaller particles were measured? Whereas in case of the bigger particles, they used few of the apparatus like gravitational method in order to have the mass of the objects which is in space, like planets and all, because by using certain set of formulas and Newton's gravitational law and all, they just focused on two of the objects, and they found the distance between two of the objects and then finally they found out the force of attraction between two of the objects, which gives the mass of one object with respect to the other object. These all things were considered, which comes under Newton's gravitational law, wherein the same concept will be discussed in case of your gravitational chapter. Until then, you will have to know the gravitation method is the one which is used in order to measure the mass of the planets. Okay, then you have got mass spectrograph, which is used to identify the mass of the charged particles, and you have your balance, which usually you see in the grocery shops and all. So for each and every objects in this universe, there are different types of instruments which you can observe exactly. Okay, so now you have got measurement of mass of atoms and molecules, and which can be usually done, that is the smallest particles can be measured with one concept, and that is nothing but atomic mass unit, AMU. It is given by atomic mass unit, and it is defined as how exactly you define one atomic mass unit, and this is very important concept. So one atomic mass unit, it is used in case of measuring the mass of the atoms and molecules. So how do you define this one atomic mass unit? It is defined as mass of 1 by 12th of mass of an atom of carbon 12 isotope, that is, one atomic mass unit is defined as equal symbol suggests that it is defined as 1 by 12th the mass of an atom of carbon 12 isotope is nothing but your one atomic mass unit. There is a carbon 12 isotope, okay? We have to consider a carbon because carbon is having certain isotopes. In that carbon 12th isotope we are taking, and here 1 by 12th the mass of an atom which is present in carbon 12 isotope is said to have a value of 1 atomic mass unit. And what is that value? It is 1.66 into 10 to the power of minus 27 kg. Kg is the general unit which you actually calculate the mass. Okay, so general unit in the sense it is the SI unit. That is all about your measurement of mass, wherein the measurement of the smaller objects is done by 1 atomic mass unit, and it is defined as 1 by 12th the mass of an atom of the carbon 12 isotope whose value is 1.66 into 10 to the power of minus 27 kg is the value which is present over there. That is all about your measurement of mass. And finally we have, as I told you, some of the common used measurement. That is, one is weight balance, that is in grocery shop what you can see, gravitational method which can be conducted by using Newton's gravitational law, and finally we have mass spectrograph which is used in order to calculate the mass of the charged particles, and finally we are getting on to the ranges of mass, how exactly the mass ranges, and it ranges from the electron level to the Milky Way galaxy, always from smaller to larger range we give. So it ranges from electron, you can read out these things like from electron it ranges from 10 to the power of minus 30, proton, the one which ranges, that is the positively charged particle, it ranges from 10 to the power of minus 27, and red blood cells in the human body, as you can see here, this is the red blood cells, it ranges around 10 to the power of minus 13. And raindrops, that is the dew drops and all, it ranges from 10 to the power of minus 6. Human mass ranges about 10 to the power of 2. And you have got your moon which ranges 10 to the power of 23 kgs is the mass of the moon, and you have earth 10 to the power of minus 25, and finally it is Milky Way galaxy which ranges in 10 to the power of 55 kg. So these are all the ranges of masses which is given to you as an example for you to understand, that is from where till where it ranges, and between that range what are the things which exist. So in our today's class we have studied about the measurement of the length as well as measurement of the mass by using certain instrument, like in order to measure the length, which are the instruments which is used, in order to measure the mass, what is the instrument is used, and the ranges of length and the ranges of mass, these and all are considered. And finally we got to know now exactly how to measure the length and exactly how to measure the mass in this universe, and which are the SI units for certain set of things. All these minute things is very much useful to you from this chapter, because you have to be very much attentive while doing this, because this is very much important for you, because this acts as a base for upcoming sessions of yours or upcoming classes of yours. Okay, let us all meet in our next class with the same chapter with the upcoming sessions. Until that, have a good day. Thank you.